this video, I am going to discuss about the some of the important examples of module 3, that is ordinary differential equations of first order. In this video, I am going to discuss previous year question papers examples of module 3, particularly module 3. Okay, let us start with first example. Solve dy by dx plus y into tan x equal to y cube secant x. This example has been asked in previous year, that is the last year 2023, in both the exams, January and February and June July exam. Okay, how you are going to solve such exam? Solution. First, observe the given equation. So write down the given equation. Which type of equation it is? Dy by dx plus y tan x equal to y cube secant x. It is of the form, in the LHS we have y to the power n form. Okay, y to the power n term. If in RHS, if we get y raised to n, such type of equations are called Bernoulli's equation. Okay, so it is a Bernoulli's equation. What is that? It is of the form dy by dx plus p into y equal to q into y raised to n form. Okay, it is for your understanding I am writing. This is how to observe the given equation first. Then once it is a Bernoulli's equation, what is the rule? We need to eliminate this y raised to n. So here in y raised to n is what? In the place of this here we have y cube. So we need to remove this y cube. So divide whole equation by y cube. So dividing by y cube, we get 1 by y cube into dy by dx plus, here already we have 1 y. So it becomes 1 by y square tan x equal to, here y cube eliminates, so it becomes secant x. Now we call this equation as equation 1. Once we get this, next we need to substitute. So we need to convert this in a standard form. Okay, so for that, put 1 by y square as t. Then when you differentiate this 1 by y square, then it is minus 2 by y cube into dy by dx. Here RHS is dt by dx. We have to differentiate with respect to x. Okay. Now, what we get? Minus 2 by y cube dy by dx equal to dt by dx. In equation 1, we have 1 by y cube dy by dx. So, equation 1 becomes, in place of 1 by y cube dy by dx, in place of this, you can substitute 1 by y cube dy by dx is equal to what? Minus 1 by 2 dt by dx plus 1 by y square is t tan x is equal to secant x. If you have not understood this, we'll write one more step here, because I want only 1 by y cube dy by dx. Then this minus 1 by 2. Minus 2 come to RHS, that is minus 1 by 2 dt by dx. Okay. Now, I want only dt by dx to write it in a standard form. So, dt by dx, take this one minus 1 by 2. Then here it is minus 2t tan x, or you may say multiply whole equation by 2. So then minus 2. Then it is minus 2 secant x. Now this equation is of the form. Which form? This is of the standard form. That is dy by dx, or here we have t. So dt by dx plus p into t equal to q form. Then where, what is p here? Where p is this term minus 2 tan x and q is RHS minus 2 secant x. For such type of equations, we have a standard solution. The solution is of the form. What was the solution? That is t into e raised to integration of p dx is equal to integration of q into e raised to integration of p dx into dx plus c. This is the standard solution of such equations. Call this as equation 2. First, let us find e raised to integration of p dx separately. So, e raised to integration of p dx is e raised to p is what? Minus 2 tan x. So, minus 2 integration of tan x dx. So, it is e raised to minus 2 as it is integration of tan x is what? It is log sec x. So, log secant x. I will write this as e raised to log sec x to the power minus 2. So, this is nothing but secant x minus 2 or secant x minus 2 is nothing 1 by secant square x. 1 by secant square x is cos square x. That is e raised to integration of p dx is cos square x. Here, this is, we have used the property e raised to n log x is nothing but e raised to log x raised to n is nothing but x raised to n. This is the property we are used. This is a standard property in ordinary differential equations. Once we get this, now equation 2 becomes LHS is t into e raised to integration of p dx is cos square x equal to integration of what is q? Q is minus 2 times secant x. What is e raised to integration of p dx? That is a cos square x dx plus c. Keep LHS as it is. Take minus 2 outside. Then sec x can be written as 1 by cos x into cos square x dx plus c. 1 cos x and 1 cos x will get cancelled. So it is minus 2 times integration of cos x dx plus c. But what is integration of cos x? So this implies LHS is 2 cos square x minus 2 times integration of cos x is only sin x. Okay, plus c. But what is t? Already we have substituted t as 1 by y square. So, in place of t, substitute 1 by y square. So, it is cos square x divided by y equal to minus 2 sin x plus c. This is the required solution of the given ODE. Okay, this is how to solve the such type of examples. Okay. Now we move on to next example. Now second example, r sin theta minus cos theta into dr by dθ equal to r square. So this question has asked in June 18 and December 19 exams. Okay. Now we need to rewrite this given equation. Okay. Just rearrange. That is cos theta into dr by dθ minus r sin theta equal to minus r square. Okay, can we write like this? Just what we did multiplied with minus sign. Okay, now divide throughout by r square. Divide, when you divide this by r square, what happens? 1 by r square cos theta into dr by dθ, and here it is 1 by r sin theta is equal to minus 1. Okay, call this as equation 1. Now, put 1 by r as some y. So, when you put this 1 by r as y, then differentiate this with respect to theta. It becomes minus 1 by r square dr by d theta is equal to dy by d theta. Okay. Now, in equation 1, we have 1 by r square dr by d theta. Replace. So 1 by r square dr by d theta becomes minus dy by dt now. So minus dy by dt into cos theta minus 1 by r is what? Y into sin theta equal to minus 1. If you want to write equation 1 becomes, okay. Or to convert it in a standard form, we need to eliminate this cos theta. So divide throughout by cos theta. So it becomes dy by d theta. We have to divide this by minus cos theta. Okay, whole equation. Now here this becomes plus sin theta by cos theta. So it becomes tan theta is equal to minus 1 by minus cos theta. So it becomes plus secant theta. Okay. Now this is of the form. This is of the form. Now we have converted this in a standard form. What is that? Dy by dt d theta plus p into y equal to q. Where what is p here? In place of p we have tan theta. In place of q we have secant theta. Then for such type of equations, what is the solution? The solution is, it's a standard solution. So it is y into e raised to integration of p into d theta is equal to integration of q into e raised to integration of p into d theta into d theta is equal to, plus c. Okay. Now, we'll find e raised to p integration of p d theta. So it is e raised to p is what? Tan theta d theta. Integration of tan theta is what? Log sec theta. So it is log sec theta. So as I said in the previous example only, it is sec theta because e raised to log x is x. Now the solution is, what is your solution now? This implies y e raised to integration of p d theta is secant theta is equal to, what is q? Q is secant theta. E raised to integration of p d theta is again secant theta d theta plus c. So this implies y into secant theta is equal to integration of secant square theta d theta plus c. But what is integration of secant theta? Integration of secant theta is tan theta plus c. But what is y? Y is what? 1 by r. So secant theta divided by r is equal to tan theta plus c. This is our required solution. Is the required solution. This is how to solve the given ordinary differential equations to find their solutions. Okay. In the next video, I'm going to solve some more important examples on this module only. Till then, keep practicing. If you have any doubt on this module, post the example or problem in the comment box. If you're not yet subscribed my channel, do subscribe. Take care. Thank you.